Okay, this time we're going to look at the problem of working out magnification from a picture of a cell or an image of a cell. So this kind of question, what they would give you is the actual size of the cell. So what I'm going to do here is I'm going to say that the actual size of the cell is 42 micrometers. Okay, why have I got that? It's just a number I've pulled out. It's an approximate size for an animal cell. Notice again, drawn. I haven't shaded anything in, even the nucleus. I've not shaded it. That's how we draw correctly from microscope practice. But how do I go about working out the magnification? Well, I know the real size, and just like before, I can calculate the size of the image. So if I measure across, I'm going to pick, doesn't matter where I measure, I guess, but let's say I've been asked to measure the length of the cell, and I measure it, and that comes in about 52 millimeters, I think. So I've measured it, and it's 52 millimeters. Okay. So what I need to think of is, what was my formula? Well, my formula is whatever I can see, the size of my image. The real thing was divided by the magnification would give me the actual size. Now, problem is, I don't know the magnification. I know the image size, I know the actual size. Now this is, if you like using the little triangles to work things out, fine. Certainly not stopping you. It's not the best way necessarily to do it. I'm going to do a little bit of algebra here, just because, but hopefully you'll see what's happening. So I know what my formula is. Remember, the first step, I want to be converting this into micrometers, and that's quite easy to do. I just multiply it by 1,000. So my image is 52,000 micrometers across. Remember, if I was working in nanometers, I multiply it by a million, it'd be 52 million nanometers across. But I'm working in micrometers because that's the scale that's useful for cells. So I'm just going to put M for magnification. That's the value I don't know. The actual size is 42 micrometers. Okay. Now, again, depending on your maths, you might go, oh, I know how to rearrange that. It's not a problem. I'm just going to go through the steps for it. What we do is we'll do the same to both sides. I want to get rid of this M. What I'm trying to do here is make my formula into a nice even straight line, because it's a lot easier to work with. How do I get rid of the M? If I multiply both sides by M, so M, I'll put the times in, M times that, and I'll put M times that over there, okay? I can cancel that out. So now I've got 52,000 micrometers equals 42 micrometers times my magnification. I'll now, I'll use the red again. To get rid of the 42, I'll divide that side by 42. And I'll put this side divided by 42. Oops. I can write properly. They can cancel on that side. So I've now changed my formula, or rearranged my formula, so that it's 52,000 micrometers divided by 42 micrometers equals my magnification. Okay, or if you like, the image divided by the actual size equals the magnification. So if I plug these numbers in, I get, where are we, 52,000 divided by 42. Now I've come up with a rather strange number, 1238.09. Let's just keep it that. Now, the odd thing with working out magnifications is nobody has a microscope with lenses that come out at 1238. You don't have a lens that size. So why have I got this strange number? Well, the problem is in my measurements. So either this measurement is slightly out, or my measurement is slightly out. And these slight differences, these slight errors in my measurement, mean that instead of getting a nice roundish number, maybe in reality it was a times 1200 magnification. But because of these little errors, I won't necessarily get a nice neat number. So when you're working out magnifications, expect that to come up. Expect it to be not perfectly dead on the magnification because of these small errors that creep in. I'm just going to mention as well, it popped into my head, when I said here don't shade, you might be tempted to shade in the nucleus if it's been stained with something. The purpose of a stain in microscopy, which is just any old chemical that's thrown in, I suppose, to say any old chemical. It's a chemical that is put in to increase the contrast. Okay, most of the cell and the organelles in here comprise mainly water. So there's not much difference between looking at, say, a nucleus and a mitochondria, or the cytosol, or any of these organelles in here. By adding a chemical, you increase the contrast. You would make it, by adding a stain, sorry, you would make one part look a different colour or a darker shade than the rest. So stains are to increase the contrast to make it easier to see. And when you are talking about microscopes, do keep pushing this term resolution. That's the key one. It's the one that people tend to forget, the ability to distinguish between these 2 points. That's a really important word to throw in. People usually forget about it. They concentrate on magnification being the important thing. It's resolution, really, the ability to differentiate between those points.